Ma'am, good evening.
Good evening, sir.
Yes, ma'am. Good evening. The next chapter, biomolecules. Now, what are these biomolecules? They are organic compounds. They are organic compounds such as carbohydrates, proteins, nucleic acids, vitamins, enzymes, which form the basis of life and which are responsible for growth and maintenance. Growth, maintenance, and reproduction of a living organism is called as biomolecules. So biomolecules are defined as an organic compound such as carbohydrates, proteins, nucleic acids, vitamins, which form the basis of life and which are responsible for growth, maintenance, and reproduction of living organism. Now, biomolecules are organic compounds represent as essential constituents of living organism in different cells. Biomolecules builds up all living systems and are also responsible for the growth maintenance. Biomolecules common to living system are carbohydrates, proteins, lipids, vitamins, hormones, enzymes, nucleic acid. Either ways we can differ. So basically, biomolecules are organic compounds such as carbohydrates, proteins, nucleic acids, vitamins, hormones, enzymes, etc., which form basis of life, which are responsible for growth, maintenance, and reproduction of living organisms. The first biomolecule what we will talk about is carbohydrates. We will learn about carbohydrates in a few minutes' time. Now, the cell and the energy cycle. Each cells obtain energy by oxidation of molecules like glucose. This glucose is obtained by a process of photosynthesis. Plants, by photosynthesis, they obtain glucose. During photosynthesis, in the presence of sunlight, plants, chloroplasts, take up carbon dioxide and water to make glucose and oxygen. So the process of photosynthesis is the plants take up carbon dioxide and water and make glucose and oxygen. Now, the first biomolecule what we're going to learn is called as carbohydrates. Now, the classical definition of carbohydrates we will learn, and then we will define what is the modern day definition for carbohydrates, and then we will continue with the topic. Now, if I write the structure of a carbohydrate, we will learn how to write the structure, how to remember the structure of carbohydrates later. Now, this molecule, what I'm writing is glucose, H and CH2OH. This is glucose. We'll come to the modern definition a little later. We'll define the classical definition of carbohydrates. So classical definition of carbohydrates is hydrates of carbon. Carbohydrates are defined, classical definition. Classical definition, or the olden days definition, is hydrates of carbon are called as carbohydrates. Now, hydrates of carbon is called as carbohydrates. That is, the general formula is CxH2O times, or we can write as CmH2O n times. Now, water, H2O, is called as hydrates. So hydrates of carbon is called as carbohydrate or was called as carbohydrates. That is the classical definition of carbohydrates. Now, even though the definition is changed in the modern days, but still the general formula of carbohydrates is still retained. So what is the general formula of a carbohydrate? CxH2O y times or CmH2O n times. M is number of carbon atom, N is number of water molecules. So hydrates of carbon is the classical definition of carbohydrates. Now, in case of modern definition, now this is an aldehyde group, CHO. There's CHO and the CH2OH, COH, and H. Okay. Now we will come to the structural aspects a little later. Now we will define the modern definition of carbohydrates. Now you can see here 1, 2, 3, 4, and 5. We have 5 OH groups. Since we have 5 OH groups, it is called as polyhydroxy. We can call it as polyhydroxy. Polyhydroxy groups containing aldehyde. Polyhydroxy aldehydes or polyhydroxy ketones. So this is an example for polyhydroxy aldehyde. Fructose is an example for polyhydroxy ketone. We will learn about that a little later. The structural aspects I will teach you a little later. Now, polyhydroxy, more than 2 will be called as poly. So here we have 5 OH. So polyhydroxy aldehydes or polyhydroxy ketones or the compounds like X, which on hydrolysis gives polyhydroxy aldehyde or polyhydroxy ketones are called as carbohydrates. That's polyhydroxy aldehyde or polyhydroxy ketone or molecules which on hydrolysis gives polyhydroxy aldehyde or polyhydroxy ketones are called as carbohydrates. Example for carbohydrates: glucose, fructose, sucrose, maltose, lactose, maltose, etc. Now, these carbohydrates are also called as saccharides. Saccharum means which tastes sweet. That's called as saccharum. So these carbohydrates are also called as saccharides. Now, coming to the classification of carbohydrates. Now, the classification of carbohydrates we will learn. Depending on the number of products formed on hydrolysis, carbohydrates are classified into 3. That is monosaccharides, oligosaccharides, and polysaccharides, depending on the number of products formed on carbohydrates. The carbohydrates are classified as monosaccharide. Mono stands for 1. Monosaccharides, oligosaccharides, and polysaccharides. So again, carbohydrates are classified depending on the number of product formed on hydrolysis as monosaccharides, oligosaccharides, and polysaccharides. Now, mono stands for 1. Now, what is this monosaccharide? Now, if this glucose molecule, the molecular formula is C6H12O6. The molecular formula of glucose is C6H12O6. When this glucose is hydrolyzed, added in water, we get aqueous glucose solution, meaning this glucose dissolves in water. This glucose will not undergo hydrolysis. That means this glucose molecule will not break into other smaller polyhydroxyaldehyde or polyhydroxy ketones. Therefore, glucose is an example for non-hydrolyzable or unhydrolyzable sugar. Unhydrolyzable or non-hydrolyzable or sugar which cannot be hydrolyzed will be called as monosaccharide. Monosaccharides are carbohydrates which will not further decompose to give smaller carbohydrates units. They are called as monosaccharides. So the first classification is mono. Mono stands for 1. Now, what are these monosaccharides? These are simple carbohydrates which cannot be hydrolyzed further to simpler compounds. Monosaccharides are further classified. We will learn this. So unhydrolyzable carbohydrates Unbreakable carbohydrates will be called as monosaccharides. Mono stands for one, saccharide stands for carbohydrate. One single unit of carbohydrates will be called as monosaccharides. Now, these monosaccharides are further classified into two. One is aldoses, the other one is ketosis. We will learn what is aldose little later. Now, aldose and ketosis we will learn little later. Before that, I need to draw the structure. And now, here this is hydrogen. As I told you, this is glucose. Now, coming to the molecule here, CH2OH, C double bond O, CHOH, COH, H, COH, H, and CH2OH. Now, this is the structure of fructose. This also has 1, 2, 3, 4, 5. 5 hydroxy. Therefore, this also is called as polyhydroxy. But you can see here, this contains a ketone group. C double bond O is called as a ketone group. Polyhydroxy ketone. Polyhydroxy ketone. The definition of carbohydrates, polyhydroxyaldehyde or polyhydroxy ketone. Fructose is an example for polyhydroxy ketone. Now, these monosaccharides are further classified into aldoses and ketosis. Now, what do you mean by this aldoses? Now, this OSE stands for sugar. OSE stands for sugar. Sugar containing aldehydes is called as aldoses. Sugars containing aldehydes will be called as aldoses, or monosaccharides which contain an aldehyde is called as aldoses. Now, glucose is an example for aldoses because it is a monosaccharide which contains an aldehyde group. Now, for aldoses, in this glucose is further classified into triose, tetrose, pentose, hexose, all that. All right. Now, pentose is a deoxyribose and ribose sugar, which is present in the nucleic acids. All right. They are all examples for pentose sugar. Right. Now, in case of glucose, the glucose is an example for aldohexose. Now, example for aldohexose, they can ask you. Sugar containing 6 carbon atom and an aldehyde group is called as aldohexose. Now, you can see this is a sugar. This is a monosaccharide. And it contains 6 carbon atom. 1, 2, 3, 4, 5, 6. So, sugar containing 6 carbon atom. In that 6 carbon atom, we have an aldehyde. So, since we have aldehyde group, it is specifically called as aldohexose. Aldopentose, when we say aldopentose, DNA and RNA will be example for ribose nucleic acid and deoxyribonucleic acid will be example for aldopentose. They can ask you. Now, coming to fructose, it is also a monosaccharide. It is called as ketohexose in specific. Ketohexose. Now, what is this ketohexose? Monosaccharides having or contain a ketone group is called as ketosis. Now, what is this ketohexose? Sugars containing 6 carbon atom and a ketone group will be called as ketohexose. Will be called as ketohexose. So, monosaccharides are carbohydrates which cannot be hydrolyzed, which cannot be broken into smaller compounds further, will be called as monosaccharides. The monosaccharides are classified into two, aldoses and ketoses. What is this aldoses? Sugars containing aldehyde group is called as aldoses. Sugars containing ketone group is called as ketoses. Now, example, glucose, fructose will be example for glucose will be example for aldose. Ketose will be example for fructose will be example for ketose. Now, in specific, we have to learn glucose in detail. So, glucose is an example for aldohexose. What do you mean by aldohexose? Sugars containing 6 carbon atom and an aldehyde group. Ketoses means sugars containing 6 carbon atom and ketone group is called as ketohexose. So this you have to remember. The next classification is oligosaccharides. Oligo means few. Oligo means few. Now, when we say few, carbohydrates which on hydrolysis gives 2 to 10 monosaccharide units, 2 to 9 in specific, but 2 to 10 they have written here, so I've taken that. 2 to 10 monosaccharide units is called as oligo. Oligo means few. So carbohydrates which on hydrolysis gives 2 to 10 monosaccharide units will be called as oligosaccharides. Now, these oligosaccharides are further classified into disaccharide, trisaccharide, tetrasaccharide, depending upon the number of monosaccharides. Now, what is disaccharide? Di stands for two. Saccharides stands for sugar. Carbohydrates, which on hydrolysis gives 2 monosaccharide units, will be called as a disaccharide. Now, for an example, if we take sucrose, if the sucrose is hydrolyzed, we get 1 glucose unit and 1 fructose unit. Since we get 2 monosaccharide units, sucrose will be an example for disaccharide. Now, if you say trisaccharide, they've given the example raffinose. The trisaccharide on hydrolysis gives 3 monosaccharide units. Therefore, raffinose will be an example for trisaccharide. Likewise, we have tetrasaccharide, pentasaccharide, goes on like this. In our syllabus, we have to learn only disaccharide. Example for disaccharide, sucrose, lactose, and maltose. We need to learn the structures of sucrose, lactose, and maltose, all that a little later. Now, coming to the next part of that's polysaccharide. Now, polysaccharides generally are non-sugars. They are non-sugar. They are not sweet to taste. Polysaccharides. These are carbohydrates with high molecular mass, which yields large number of monosaccharide units on hydrolysis. Greater than 10 monosaccharide units on hydrolysis it will give. Therefore, they are called as poly. Poly here in this context stands for more than 10, because up to 10 it's called as oligosaccharide. So more than 10 will be called as polysaccharides. So carbohydrates, which on hydrolysis gives more than 10 monosaccharide units, will be called as polysaccharide. Example for polysaccharides: cellulose, starch, glycogen is example for polysaccharides. And polysaccharides has a general formula C6H10O5 N times. This is a general formula of polysaccharides, C6H10O5 N times. Now, coming to the next part of the topic, this is classification. Sometimes they can ask you classification of carbohydrates itself. So depending on the number of monosaccharide units, they're classified as monosaccharide, oligosaccharide, and polysaccharide. We have learned in detail the examples also. Now, classification based on taste. Carbohydrates are also classified based on their taste. They are classified as sugars and non-sugars. In general, monosaccharides and disaccharides are crystalline solids, soluble in water, sweet to taste, and they are known as sugars. So sugars are carbohydrates which are sweet to taste and which are soluble in water. Now, example, glucose. We would have tasted glucose. We would have tasted sucrose. Sucrose is nothing but the sugar what is in the kitchen. So all these will taste sweet, and they are crystalline in nature, and they are soluble in water. So carbohydrates, which are crystalline in nature, soluble in water, and sweet to taste, are called as sugars. Now, non-sugars, I clearly explained, they are polysaccharides. All polysaccharides are not sugars. All polysaccharides are amorphous. They are insoluble in water, and they have no taste. They are tasteless. They are known as non-sugars. Example for non-sugars: cellulose, glycogen, starch. They're all examples for non-sugars. So non-sugars are amorphous in nature, insoluble in water, and they do not give taste, sweet taste. They are tasteless. Now, the third classification of carbohydrates is classification into reducing and non-reducing sugar. It's important, reducing and non-reducing sugar. Now, what is this reducing sugar? Carbohydrates which contain free aldehyde group or ketone group and reduces tolerance reagent and failings of solution are known as reducing sugar. See, all monosaccharides, when we say all monosaccharides, it's glucose, fructose, galactose. All these are example for reducing sugar. Now, in case of glucose, if you remember, there's a free aldehyde. In case of fructose, there is a free ketone group. So, sugars which contains free aldehyde or free ketone group will be called as, and which will reduce tolerance reagent and failing solution are known as reducing sugars. All monosaccharides, that is all aldoses and ketoses are reducing sugars. Now coming to the non-reducing sugars, carbohydrates in which aldehydes and ketones are bonded and do not reduce tolerance reagents and failing solution are called as non-reducing sugars. Example, maltose, lactose are example for non-reducing sugars. So what is non-reducing sugars? Carbohydrates in which there is no free aldehyde and ketone are called as non-reducing sugar. And these failing solution, they will not reduce failing solution or now coming to the monosaccharides in specific. The most common monosaccharides are glucose and fructose. The formula is as follows. This is the formula of glucose and this is the formula of fructose. Now, glucose and fructose have same molecular formula, C6H12O6. The molecular formula of glucose and fructose, C6H12O6. We will learn the structure of glucose and fructose, how to write the structure and how to remember the structure in few minutes time now. Now, we will learn, see, glucose and fructose, they are examples for monosaccharides. Glucose is an example for aldohexose, and fructose is an example for ketohexose. In general, this is aldose, and this is ketose. Aldose and this is ketose. Now, we will learn glucose in detail. Now, this glucose is also called as dextrose because it rotates, glucose molecule rotates the plane polarized to light clockwise. It's an optical isomer. Glucose is optically active. It rotates the plane polarized light clockwise. Since we obtain glucose from grapes, we call this as grape sugar. Glucose occurs in nature in free as well as in combined form. It is present in sweet fruits and honey. Ripe grapes contain around 20% glucose. Ripe grapes contains around 20%. So glucose is present in major percentage in ripe grapes. Therefore, glucose is also called as grape sugar. Glucose occurs in nature in free as well as in the combined state. It is present in sweet fruits and honey. Ripe grapes contain nearly 20% of glucose. Preparation of glucose. Now, glucose can be prepared in various ways. The preparation of glucose is not in our syllabus. We have to learn with the structure of glucose and the properties of glucose. Now, one or two examples. This is a simple example we will learn, and then we'll continue with the properties of glucose, structure, elucidation of glucose. Now, from sucrose. Sucrose is C12H22O11. Sucrose, when we hydrolyze in the presence of acid, we get glucose and fructose. So glucose can be prepared on hydrolysis of sucrose. When sucrose, or otherwise, in other words, if sucrose is hydrolyzed, sucrose as a molecular formula C12H22O11. When the sucrose is hydrolyzed in the presence of dilute sulfuric acid or hydrochloric acid, we get glucose and fructose. Otherwise, the next method is from starch. Starch is a polysaccharide. It is a non-sugar. This starch, when we hydrolyze, starch on hydrolysis in the presence of dilute hydrosulfuric acid at 393 Kelvin under pressure, you get glucose. So otherwise, we can say starch is a polymer containing glucose as the monomeric units. So starch on hydrolysis in the presence of sulfuric acid, we get glucose. So the molecular formula of glucose is C6H12O6. Now, properties of glucose. What are the properties of glucose? We are going to learn acetylation, oxidation, hydroxylamine, hydrogen cyanide. So 5 or 6 properties we are going to learn. Oh, so many properties are there. Not necessarily these so many properties. Few properties which are important we will learn, but we're going to learn it in different order. It is not in the same order as acetylation or what's given. Now, the first one is when any new molecule is synthesized, it is subjected to qualitative and quantitative analysis. Qualitative and quantitative analysis. Qualitative means detection and quantitative is estimation. Qualitative means detection of what all elements is present. That is called as qualitative. Quantitative is finding out how much of percentage are present. Now, for an example, if water is synthesized, we will analyze for water whether we have hydrogen, oxygen, carbon, nitrogen, sulfur. This water will answer only test for hydrogen and oxygen. So that is qualitative analysis. Once you identify what all elements is present, now we should know what percentage of oxygen is there, what percentage of hydrogen is there. That's called as qualitative analysis, quantitative analysis. Once qualitative and quantitative analysis is performed, then we can find the empirical formula. Now, once empirical formula is found, we can find the molecular formula. So the first step is the qualitative analysis and quantitative analysis of the molecule glucose gives the information that the molecular formula of glucose is C6H12O6. Now, the first point is qualitative and quantitative analysis or molecular mass analysis of glucose gives the information that molecular formula of glucose is C6H12O6. When molecular formula of glucose is C6H12O6, it means we have 6 carbon atoms. Now, when we have 6 carbon atoms, now we get a next question, whether this carbon atom is in the ring form or in the open chain form. Now, we have to elucidate the structure, determine the structure of glucose. That is what we want to learn here. Properties of glucose. When we say, how do we arrive at the structure of glucose? Now, before we understand the chemical properties or the reactions, now I want you to remember how to write the structure of glucose. Since we understand from the molecular formula, it has 6 carbon atoms. Write 6 carbon atoms in a straight chain. 3, 4, 5, and 6. 6 carbon atoms. This, you number it. 1, 2, 3, 4, 5, and 6. Now, the first carbon atom, we write an aldehyde group. CHO is an aldehyde group. The last carbon atom, we will write a primary alcohol group. This is primary alcohol group because carbon is bonded to only one carbon. Carbon contains 2 hydrogen. Therefore, this is primary carbon atom. Primary carbon atom containing OH groups. Therefore, it's primary alcohol. The third carbon atom, we will write hydrogen on the right-hand side. Now, second carbon atom, OH on the right. Fourth carbon atom, OH on the right. Fifth carbon atom, OH on the right. If OH is on the right side, hydrogen has to be written on the left. If hydrogen is on the right side, OH has to be written on the left. Here it will be H, and here also it will be H. This will be the structure of glucose. Now, how do we remember the structure of glucose? This is open chain structure of glucose. We have to learn the Haworth structure of glucose, all that we're going to learn in a few minutes time today. Now, 6 carbon atom, we write it in a straight chain. First carbon atom, we write it CHO aldehyde group. Last carbon atom, it's primary alcohol group. Second to fourth carbon atom, it's secondary alcohol groups. So glucose contains 1 primary alcohol, 4 secondary alcohol, and 1 aldehyde group. The only thing is this third carbon atom, hydrogen will be on the right. Now, this structure you have to remember so that we will learn the reaction. So I'll write this as the second. The first one will be called as the elemental analysis. Elemental analysis. This will be called as the first one. Elemental analysis. Qualitative and quantitative analysis gives the empirical formula, and the molecular formula is C6H12O6. Now, the first property what we're going to learn is reaction with hydroxylamine. Now, when we say reaction with hydroxylamine, this is first, and this is second, and this also will mark this as second A, and this will mark this second B. Now, if I write an aldehyde group like this aldehyde group, when we allow it to react with hydroxylamine, it is NH2OH. So what happens is these two hydrogen gets eliminated as water, and we get RCH, double bond N and OH. We get a product called as oxime. So when we don't know the structure of glucose, when this glucose is allowed to react with hydroxylamine, we get glucose oxime. Now, when we say glucose oxime, I told you the structure of glucose. Here, we can write the aldehyde structure like this. CH, double bond O. When this is allowed to react with hydroxylamine, so what happens? These two hydrogen and oxygen gets eliminated as water. In place of this oxygen, nitrogen goes. So we get glucose oxime. We get glucose oxime. This is first reaction. The second reaction is same. I'm taking a general aldehyde group in order to explain this. When this is allowed to react with hydrogen cyanide, hydrogen attacks oxygen, cyanide attacks carbon, we get RCH, OH, and Cn. This is called as cyanohydric. What is the cyanohydric? Carbon containing OH and Cn group will be called as cyanohydric. So this is glucose. We don't know the structure yet. When this glucose is allowed to react with hydrogen cyanide, we get glucose cyanohydric. So these two reactions prove that glucose contains an aldehyde group. Aldehyde group, or in specific, it contains carbonyl group, because the reaction is taking place between carbon and oxygen. Therefore, these two reactions proves that glucose contains an aldehyde group. The second one. The third is, this is third, oxidation with nitric acid. This is third step. Now, strong oxidizing agent like nitric acid oxidizes both CHO group and CH2OH group into carboxylic acid. So this aldehyde and this primary alcohol will be oxidized to carboxylic acid. This is called as glucaric acid. So formation of glucaric acid gives the information glucose contains an aldehyde group as well as a primary alcohol group. So strong oxidizing agents like nitric acid. Now, if you take bromine, If you take bromine, it's a mild oxidizing agent. It will only oxidize aldehyde to carboxylic acid. So if you take bromine, you get COH and you get CHOH 4 times and you get CH2OH. This remains as such. This is called as gluconic acid. Gluconic acid. If you use strong, this is mild. If you use strong oxidizing agent, both aldehyde as well as alcohol is getting oxidized to form glucaric acid. So this oxidation with nitric acid shows glucose contains a primary alcohol group. This is third. Now, the question is, we all know that it contains 5 OH groups. Now, when it contains 5 OH group, now we know carbon valency is 4. Now, if I write like this, I don't know whether this molecule does not exist, but we understand that carbon valency is 4, therefore you can have 4 OH group on a single carbon atom. Not possible. How do you prove that? Now, in order to prove that, this glucose is acetylated. This is the writing. We are going to take this as the fourth step, acetylation. Acetylation proves that glucose contains 5 OH groups on different carbon atoms. Now, when we say 5 OH groups on different carbon atoms, now acetylation, now for an example, if I have an alcohol group, I have an alcohol group like this. And this is allowed to react with acetic anhydride. When this is pentacetic anhydride, acetic anhydride is CH3, CO, CH3, CO, and O. This is acetic anhydride. So what happens? Pentaacetate group. Now I can show a bond breakage here. This hydrogen attacks this oxygen and gets eliminated as a byproduct like acetic acid. And in place of this H, this carbon goes. So we get CH3, you have O, you have carbon double bond O, and you have CH3, acetate. You get an ester. Since I have one OH group, I have one ester. But when we acetylate glucose, we get 5 ester groups. This 5 ester groups which are formed proves that the OH groups are present on the different carbon atoms. Since the OH groups are present on the different carbon atoms, we get 5 acetyl groups, or this is called as pentaacetate. Pentaacetate groups. Now you can read the statement. Glucose reacts with acetic anhydride to give glucose pentaacetate. This confirms glucose contains 5 hydroxyl group on different carbon atom. This is the fourth reaction. These 4 reactions are enough to justify the structure of glucose. Now, these all are the addition reactions which are not there in the syllabus, but we will quickly go through this. Action with the tolerance reagent. What is this tolerance reagent? Ammoniacal silver nitrate. Ammoniacal silver nitrate is called as tolerance reagent. Now, when silver nitrate and ammonia is allowed to react with each other, and in the presence of sodium hydroxide, we get a clear solution. That's called as tolerance reagent. The chemical formula of tolerance reagent is this. AgNH3 twice OH. It's a complex. Diamine silver hydroxide. So this is the complex. Now, when glucose is treated with tolerance reagent, you can see here this aldehyde group is oxidized to acid. And here silver has +1 oxidation state. Here silver has 0. Silver gets reduced. Since silver gets reduced, tolerance reagent gets reduced. This tolerance reagent is called as an oxidizing agent. Now we can say tolerance reagent oxidizes glucose to gluconic acid. Gluconic acid. Now, similar reaction with failing solution. Copper is in +1 state. Now you can see again here, this aldehyde is oxidized to carboxylic acid. So failing solution oxidizes glucose to gluconic acid, giving a red precipitate of cuprous oxide. Now, actually, I had to tell you, this was the second point we should have learned. This should have been the second, and the third and fourth oxidation, acetylation will be this. This will be the third. Now, reaction with hydrogen iodide, it's called as reduction. So, glucose on prolonged heating with hydrogen iodide in the presence of red phosphorus, we get normal hexane. This formation of normal hexane shows that in glucose, all 6 carbon atoms are linked linearly. All 6 carbon atoms are present on the straight chain. So this is just supposed to remember for structural elucidation. These points can be asked for 2 marks. Each point what we learned can be asked for 2 marks. Now this ozone formation we do not have in our syllabus, so don't worry about it. Reaction with alkali, glucose, this also is not there. Reaction with alkali, T-glucose on heating with concentrated sodium hydroxide. Glucose first turns yellow and then brown and finally resinified. With dilute sodium hydroxide, glucose undergoes reversible isomerization and it's converted into a mixture of D-glucose, D-mannose, D-fructose. This reaction is known as Lowry-de-Bruyn Ickenstein arrangement. This is not there in the syllabus. Formation of glucoside. Glucose reacts with methyl alcohol, the presence of dry HCl to give methyl glucoside. This reaction is also not there in our syllabus. We'll have to learn the cyclic structure of glucose. Cyclic structure of glucose. That cyclic structure, they will not ask you this ring structure. They will ask you to write the Haworth structure. Haworth structure of glucose. Now, we will quickly learn the Haworth structure of glucose. Now, this glucose, since it has 6 carbon atoms, it forms a 6-membered ring. The 6-membered ring are called as pyranose ring. 6-membered ring are called as pyranose rings. Now, we have alpha glucose and beta glucose. Before we go to the Haworth structure, you can see this is alpha D plus glucose and this is alpha D minus beta D plus glucose. Now, as I wrote the structure of an aldehyde, 1, 3, 4, 5, and 6, OH and H and OH and OH. Here it's H, here it's OH, here it's H, and it's OH. Now, aldehyde group, we can write it like this. Instead of writing the hydrogen on the top, I can show it on the left-hand side. Now, what happened? This is the first carbon atom, this is the 5th carbon atom. Now, this is hydrogen. Now, this hydrogen attacks the oxygen. So what happens? The pi bond breaks. The pi bond breaks. When the pi bond breaks, now the carbon 1 and carbon 5 gets bonded to oxygen. You can see here carbon 1 and carbon 5. Here OH is on the right hand side, therefore it is alpha. And in the 5th carbon atom, the OH was on the right hand side, therefore it is D plus. Now, if I write the aldehyde group on the left hand side, like this, Same thing happens. Hydrogen OH attacks here. The pi bond will break and this carbon will get bonded here. You can see it's wrongly written. Here it is H. All right. So this will be called as beta D plus glucopyranose. Now they are anomers. Why they are called as anomers? You can see here plus sign shows that both are anomers. Now anomers, the configuration differ only at the first carbon atom. You can see at the first carbon atom, here OH is on the right, here OH is on the left. Therefore, they are called as anomers. This plus sign signifies it as anomers. Now, coming to the Haworth structure, I think we should learn the Haworth structure, disaccharides, all that in the next class. Ma'am, I'll stop the class, ma'am. Ma'am?